In this video, we're going to debrief the second activity, which is about the Pepsi soda contest. All right, so the claim by the soda company is that 1 in 6 bottles contain a prize, and then 30 students go and buy sodas, and only 2 of them win a prize. Okay, so already we're starting to feel a little suspicious. Okay, so in question 1, we calculate, well, how many winners would we expect to get with 30 bottles? And so we just kind of multiply the number of bottles by the likelihood 1 in 6 to get 5. Okay. Now I want to label each of these values here. Okay. So 30, we're going to label that as n. It's our sample size. And the 1 out of 6, that's p, our probability. Okay. So we're just doing n times p, okay, to figure out the expected number. Okay. All right, so we expect 5 winners, but we only got 2 winners, right? Again, some suspicion starts to creep into our minds. So we have some evidence that Pepsi is lying, since 2 is much less than what we expected in 5. All right, so let's just make a note that we have some evidence. Since 2 is less than 5. Okay, but I mean, is it that much less than 5? I mean, it's only a couple values less than 5, right? So isn't it possible that Pepsi is telling the truth and maybe these 30 students got unlucky, right? That's one possible explanation. And the other possible explanation is, of course, that Pepsi is lying. Okay, so we've got to decide which of these two explanations is more likely. Okay. And so the way we do that is we start with one explanation. We're going to assume that Pepsi is telling the truth. Okay. And then we'll figure out, well, if they're telling the truth and the likelihood of winning is really 1 in 6, well, what sort of outcomes would we expect to get purely by chance? Okay. And so you did this part in your groups. You either used the real dice or you used the website random.org. Here I had done it. Here I just did 30 dice rolls using the website to figure out, how many winners would we get in 30 customers. So the first time I did the simulation, I only got 3 winners, and the second time I did the simulation, I got 4 winners. Okay, your results are obviously going to vary, right? Because dice rolls are random, whether you're using real dice or simulated dice on a website. Okay. Now, hopefully you guys made a poster. I have no idea what that poster looks like since I'm not there with you. Okay, but I do know that for question 7, right, when it asks to find the probability of getting 2 or fewer prizes, what we want to do is focus on this region of our dot plot. Okay, so this was the class's result. The actual result was 2 winners. Okay. Now, when we did the simulations, right, the question is how many dots were in this region? Okay, so you'll probably set it up as a ratio first, right, and then convert it to a percentage. Okay. Now, let's use that percentage to answer question 8. Okay, and here I'll give you a guideline. Okay, if the percent of dots is greater than 5%, okay, what that means is the actual result is still somewhat likely to have occurred just by chance. To occur by chance. Okay, which in this context means the class just kind of got unlucky this time. Okay. However, if the percent of dots in that region were to be less than 5%, okay, then it means the actual result is unlikely to have occurred by chance. Right, unlikely because less than 5% as a measure of likelihood is pretty low. Okay, actual result is unlikely to have occurred by chance. So if we're saying it's unlikely that chance was the factor, then we have to go back to the other explanation. And the only other explanation we had was that Pepsi's lying. Okay? So if we think it's unlikely that chance was the reason, then we say we found convincing evidence that Pepsi was lying. Okay. In the first scenario, if the percentage of dots was above 5%, we'd say that we don't have evidence, we don't have enough evidence that Pepsi is lying. And so before we flip the page, again, I just want to make the distinction between having some evidence, right, just a value less than what we expect, okay, versus convincing evidence, right, which uses likelihood, right? How likely is it that we could have gotten this result by chance? Okay, if its likelihood is above 5%, okay, could have happened by chance. If the likelihood is so low, so close to zero, less than 5%, okay, then we don't think it could have happened by chance, okay, meaning there's some other reason for why it happened. All right, let's flip over to page 2. All right, so when you were rolling the dice to, simulate the 30 students buying sodas, right, you were doing a simulation. Okay? So the definition here, it's a way to model random events so that the simulated outcomes closely match the real world outcomes. Okay. So because we had a probability that was 1 in 6, using dice made sense because dice have 6 sides. If we were doing something where the likelihood was 1 in 2, right, then we could like toss a coin because a coin has 2 sides. So we can use things like dice, coins, spinners, cards, or even just a random number generator to perform a simulation. All right, so the last question on the front side was asking, whether we had convincing evidence that Pepsi was lying. Okay. And so really we want to know, did we have evidence against their claim? Okay. So the way this works is we always assume the claim is true, right? So that's why we were using dice, because we were assuming that the 1 in 6 likelihood was true. And then we found the probability of getting the actual result or something more extreme. Okay. And that's what we're doing when we are counting the number of dots that are 2 or less, right? What's the likelihood of getting the actual result or something more extreme? Okay. All right. So if that probability, if the percentage of dots is less than 5%, then we state that the result is statistically significant, and we say that we have evidence against the claim. All right, but if the percentage is above 5%, then the opposite would be true, right? The result is not significant, and we don't have enough evidence against the claim. All right, so depending on how much time is left in the period, you can work on this in your groups, or if we don't have enough time, then I'd ask you to do that for homework and then check your work online. I'll post the answer key on Canvas.